So before I start, I guess I'll take any questions from people in the meeting. So if anybody has any questions about, I guess, the assignment 5, now would be a good time to ask. So does anybody have any questions? All right, I guess not. Assignment 5 is not terribly difficult. It is a little tedious because I did ask you to implement a lot of classes, and they're all pretty similar. So there's a small amount of tedium, unfortunately, involved in this particular assignment. I don't think it's overly difficult, this one, and I think it's a little shorter than your previous one, actually. Someone, I think, 124, might be 121. Someone has asked for an extension. Now, the problem with the extension is that it takes you into, I guess it takes you into the pre-exam period, which I'm not crazy about. But if you do need extra time, I don't mind if you hand it in by the Monday after class ends. So that'll be not next Friday, not next Monday, but the Monday after. And you won't receive a late penalty or anything like that. I don't want to extend it much longer because you guys have exams to study for. I think it's a question in chat. What can we use for assignment 5P9? Is it just command, or can we use 0.2 things? Oops, sorry. That's a good question. Part 9. Oh, here. I see. Create and implement your own topics command class. Can you just use, or can we use 0.2 things? You're going to have to clarify what you mean by that, Wesley. So certainly inside your class, you can definitely use 0.2. Inside your class, you can use whatever you want, if that answers your question, right? Did that answer your question, Wesley? I think. Okay. Yeah. So my expectation is that your command class, your composite, your own. Yeah. So you're going to make some sort of. You're going to make some sort of class that does something, right? So it draws something, right? Something. Something slightly interesting. It doesn't have. You don't have to don't go out of your way to. Don't go well out of your way to make some crazy shape. Like, for example, don't try to do that, for example, right? I mean, if you have time, go ahead and go nuts, but that's not the expectation of this assignment. But to generate an interesting shape, you probably need to make 0.2 objects, or at least you need to generate X and Y coordinates, right? So I think the answer to your question is yes, you can use 0.2 objects, but you're probably, but you should also be making other command objects as well. Right. If you've done the, yeah, you could definitely use other 0.2 objects. I forget what I gave you. Did I give you? What does the test shape class look like? I don't remember if I gave you exactly what that code looks like. No, I didn't give you anything like that. There is the way this shape is generated up here. So the way this thing is generated up here is it repeatedly calculates the new point to move to. And then it figures out how to turn the turtle and move the turtle so that it goes to the next point. If you can do that, that's the easiest way to generate more complicated shapes, right? So for example, if you can figure out a sequence of points that you want to move to, then that's one way to generate an interesting shape. The problem with doing that with the turtle is the way the turtle moves, you have to turn the turtle so that it's facing the point that you want to move to. And while that's not a difficult calculation to do, when you go to implement it in a programming language, it's a little bit different than how you would do it mathematically. Essentially, if you're interested in doing it that way, you have to take an arctangent somewhere. And the way that arctangent works is that it always returns a value. I forget now. It's never, so you want a value between 0 and 360 degrees. But the way ATAN works is that it returns a value that only has a range of 180 degrees. So you have to do something slightly different. But that's going a little bit beyond what I'm expecting most people to do. If you want the details, you can ask me about them later. Okay, any other questions about assignment 5? Okay, good. So the topic of today's lecture is inheritance. And so this is the introduction to inheritance. It's a little bit different. It covers the same material, but it's different than the discussion in the notebooks, right? So, I mean, you guys can read the notebooks, and you have been reading them, and I think most of you have been reading them. So this discussion is a little bit different. The quote here that you see on the screen is taken from the official Java tutorials. And so when they describe inheritance, basically they're describing one particular type of inheritance. So they say when you want to make a class and there's already a class that includes some code that you want, you can just inherit from that class. Right? So what they are describing here is inheritance for code reuse. And it's actually not the best use of inheritance, but it's the way it's typically introduced to people when they first see inheritance. Right? So the idea is inheritance is a relationship between two classes where one class is derived from the other class, or one class inherits from the other class. So in Java, everything inherits from something called object. So every class in Java inherits from this class called object, right? So that's what all these empty boxes are trying to show you, right? In Java, there's one class at the top of the hierarchy. A subclass is a class that's derived from another class. So in this picture here, everything below object is a subclass of object. Superclass is just the opposite relationship. So it's the class from which a subclass is derived, right? So in other words, object is the superclass of every other class in the language. Right, that's just the way that Java is designed. Not every object-oriented programming language works this way, right? You'll often see other names than subclass or superclass, right? So in Java, you'll often see extended class because extended is the keyword. Extend is the keyword that Java uses for inheritance. You'll often see derived class when people talk about object-oriented languages, or child class. Class, you'll often see base class or parent class. Okay, in this example, X is the superclass, Y is the subclass. This thing here is the UML diagram that shows the relationship between the two classes. Right? The arrow always goes from the subclass to the superclass. And the arrow always looks like this on the UML inheritance, on the UML class diagrams. The other arrow, the open arrow, means something else. Okay, so Java is, I would say it's actually a bit unusual for object-oriented programming languages in that it actually has one object at the top of the hierarchy, right? So it's always Java lang object. It's unique, right? So it's the only class in Java that has no superclass. And it is the class from which all other classes are descended from. Right, so it's you can think of it as being the ancestor of all other classes in Java. Now, before we started talking about inheritance, we were making classes, right? So in the notebooks, you make the point2 class, the card class, You made the Sokoban class in one of the assignments, and we never said anything about inheritance, right? But I just told you, object is the parent of everybody, right? Or it's the ancestor of every other class. So the rule in Java is if you make a new class, but you don't explicitly state what the superclass is, then object is your superclass. Right? You don't actually have to write anything special when you make a new class that is not that you're not intending to use as part of an inheritance hierarchy. In Java is also unusual, a bit unusual in terms of object-oriented languages, in that you can have a superclass that has many subclasses, right? So here, Y, Z, and W, these are all subclasses of X. But Y, Z, and W in Java, they're only allowed to have one superclass, right? So the superclass for all of these is X, right? Object is sitting up here somewhere, right? So it's not the direct superclass to Y, Z, and W. It's still considered a superclass. It's just higher up in the hierarchy. Right? So when you have a language where a class, like Y, has only one superclass, that's called single inheritance, right? So if you think of this in terms of a parent and child relationship, basically it's saying that the child class Y only has one parent, in this case X. Right? There are other object-oriented languages where your subclass can inherit from more than one superclass. So you have 2 or 3 or as many as you want superclasses for a single class. Java uses single inheritance, and that eliminates one set of problems that you have with multiple inheritance. It's not, the problem that it solves is not important for our purposes right now. Okay, let's see. So in Java, everything inherits from object, right? So everything is part of a chain that goes back to object. So here we have a subclass A, right? It inherits from Z, Z inherits from X, and X inherits from object, right? So we say that a class is descended from all of the classes in this chain going back to object, right? So A is descended from Z and X and object. Everything above A, right? So all these classes here, those are called the ancestor classes of A, right? They're all superclasses of A. Z is what's called the direct superclass to A. Another important part about this picture, right here, is that in Java, actually in every object, in all the object-oriented languages, the type of A, right? So you know that a class defines a type, right? When you have a class that's part of an inheritance hierarchy, A, this class down here, actually has many types, right? So one of its types is A, but another one of its types is its direct superclass Z, right? And in fact, all of its ancestors are also, A also has the type of all of its ancestors, right? So here A actually has 4 types, right? Its own type A, type Z, type X, and object, right? And what that means in Java is anywhere you need an object, a big O object, right? So for example, the equals method has a parameter whose type is object. So anywhere you need one of these, you can pass in any one of these. Okay. So for equals, where the parameter is object, I can pass in an A, a Z, or an X, or anything else, right? Or anything else, because the parameter type is object, and object is the superclass for every type in the language, right? And so that's why equals is designed the way it is, right? You can pass in anything to equals, any reference type to equals, and the method works, right? And that's why it has the signature equals big O object. Similarly, if you have a method and its parameter has type X, you can pass in a Z or an A, right? And if you have a method whose parameter is type Z, you can pass in an A, right? So what this picture is trying to show you is that A, right, is substitutable for Z, X, and object, right? Anywhere you need one of these, you can use one of these. Right? And so that's the principle of substitutability that the notebooks talks about. Right? I think it's in the second last or last notebook that's on the that you're asked to read. Right? Is where we talk about substitutability. Okay, so now the question is why do you want to use inheritance? Right? So the quote way back at the beginning is one reason. Right? So there's this potential that you can reuse code that's already written. Right? And so how does this reuse happen? So the way it happens is that a subclass inherits everything that's not private from its superclass, right? So it inherits all of the fields and methods. It does not inherit constructors. A class never inherits a constructor, right? Constructors are special. They're not considered to be what are called, Java uses the term member. So constructors are not considered to be members of the class. Is that true? Yes, that's true. In Java, constructors are not considered members, right? Fields and methods are members of a class. So everything that's not private, the subclasses inherit. Okay. So if there's an existing class that provides some of the functionality you need, right, you can derive a new class from the existing class, right? That's what the introductory slide basically says. The new class gets direct access to all of the public and protected fields and methods, right? So your derived class, your child class, can use anything that's public or protected from the superclasses, right? And that's great. So you get all of this code reuse, right? Everything that the superclass has already implemented for you that's public or protected, you get to use. But then you can do some extra stuff too, right? So in your new class, you can bring in new methods and fields. And then the new class can redefine or override its superclass methods, right? And you've actually already done this in the course, right? So when you override equals, what you're doing is you're replacing the implementation of equals that your class inherited from object, right? When you override toString, you're replacing the version of toString that your class inherited from big O object. Right, so this isn't anything new. You've already done it before. Okay, so inheritance is supposed to model what's called the ISA relationship. Right, so ISA means is substitutable for. That's what it really means. So what is it actually? So from a Java point of view, ISA means anywhere you have a superclass or an ancestor class, you're allowed to use one of the subclasses. Right? So suppose you have a method with one parameter of type object, like equals, right? So this is called sum method, but you can just replace that with equals if you wanted to, right? Inside the method, you're going to do something with the parameter obj, right? You know from implementing equals that inside the equals method, you end up casting obj to the type that you want, right? So for example, in point 2 equals, you end up taking obj and casting it to a type to a point 2 object. Okay, somewhere, anybody that's calling some method, right? They have to pass in one of these, right? They need to pass in a type, a reference whose type is object, or whose type is substitutable for object, right? Everything is substitutable for object in Java. So I can make a string and pass that into the method, right? That's fine, right? String is an object, right? I can make a set and I can pass that to some method, right? That's okay because hash set is an object, right? And you can make any reference type here, right? You can make a date, you can make an array list, you can make a map, right? And you can take all of those and you can pass it to some method, right? Because all of those are substitutable for object. So what you have to be careful of is that ISA has nothing to do with the real world, right? So this is purely a programming construct, right? So it has everything to do with how the programmer has modeled the inheritance hierarchy, right? So the classic example that many programmers are taught is the circle and ellipse problem. Right. Okay, so the question is, right, should circle inherit from ellipse? Right. So so everybody, I'm sure everybody here knows what a circle is. Hopefully, you know what an ellipse is, right? So an ellipse is an oval shaped. You can think of it as a circle that's been stretched in one direction, right? Now, mathematically, right, a mathematician will say that a circle is a kind of ellipse, right? It's just a stretch. It's a special type of ellipse, right? So it's an ellipse where both the axes have the same value. The semi-major and semi-minor axes have the same length, right? Which in a circle you call the radius, right? So mathematically, circle is an ellipse, right? The question is in your program, should circle be an ellipse, right? And the answer is maybe. Right? So if an ellipse object can do something that a circle object cannot do, right? Then circle is an ellipse is false for the purposes of inheritance, right? So remember what this relationship means, right? Circle is an ellipse. As far as the programming language is concerned, that means that anywhere you have an ellipse, you can use a circle, right? Now, what you have to remember is, or what you have to be aware of, is that if ellipse has some method, right, that circle can't support, then you have a problem, right? Circle is no longer substitutable for ellipse, right? Because there's something that an ellipse can do that a circle can't do, right? So ISA means you can substitute the derived class for one of its ancestors, right? So anywhere an ellipse is needed, if this picture is true, anywhere an ellipse is needed, I can use a circle, right? So if circle can't do something that ellipse can do, then I can't safely substitute a circle for an ellipse, right? So for example, so this is a method somewhere in the ellipse class, right? So the ellipse class says it has a method with this contract, right? The method changes the width and height of the ellipse to the specified width and height, right? So in other words, when you call set size with that width and that height, right? The field's width and height of the ellipse are changed, right? So for example, you can have a width of 1 and a height of 10, or a width of 10 and a height of 1, or something like that, as long as this precondition holds, right? So there's a precondition here on the method that says that the width and height both have to be greater than 0. Okay, now, what's the problem? Oh, wait, we're just going to quickly check something here. Okay, so what's the problem with this method as far from the perspective of circle, right? So a circle is an ellipse where the width and height are always the same value, right? Circle is going to inherit this method, right? So circle is going to inherit the set size method, right? And anybody calling the set size method, they're told that this is what happens, right? This is the contract for the method, right? So whatever happens inside this method, this had better happen, because this is what you're telling everybody happens, right? So you're going to change the width and height of the ellipse to the specified width and height, right? But you can't do that with a circle, because then it's not a circle anymore, right? If you change the width and height to something different on a circle, it's no longer a circle, right? And now you have a problem, right? You have a problem. I can't take this method away from ellipse, right? It's public in ellipse. So I'm not allowed to hide it inside of circle, right? In other words, I can't make it less accessible inside circle. The language won't let you do that, right? I have this method, and it's going to change the width and height because you inherit it from ellipse. Now, inside of circle, you can change the definition of set size, right? So you can change set size so that it always sets it to that, or so it sets both the width and height to that, or both the width and height to that, right? So there's nothing in the programming language stopping you from doing that, right? The problem is when someone uses your class, right? Or more precisely, when someone uses this inheritance hierarchy right here, right? They're going to be surprised, right? Because somewhere, at some point in time, they might have a method that calls set size on an ellipse, right? So there might be they have some method, it takes in an ellipse as a parameter. Inside that method, they call set size, and they're expecting this to happen, right? Now, when they pass in a circle, this suddenly no longer happens, right? And depending on what they've written, that might be a problem, right? And you might ask yourself, well, well, it's not really a big deal, right? The circle is acting like a circle, and the problem is it is a big deal because you don't know why they've written the method the way they've written it, right? Right. So in other words, you've broken they've written a method using a contract that you supplied, right? And then you've given them a class that doesn't satisfy the contract, right? And that's not a good thing, right? So in the real life, whoops, sorry, right? So in mathematics, yes, circle is an ellipse, but in a program that might not, in an inheritance hierarchy that may or may not be the case, right? Now, if ellipse has no set size method, then you might be okay, right? You're okay if circle can do everything that an ellipse can do, right? Then you're fine. Then you can go ahead and do this. But if there's even one thing that an ellipse can do that a circle can't, then you should not have circle inherit from ellipse. Okay, so let's look at another example of inheritance. Okay, so hopefully you've read the notebook that tells you what a stack is. So if you're in computing science, then you're gonna, in second year, you're gonna take a course called CISC124 data structures. And in data structures, you may or may not learn about this thing called a stack, right? So a data structure is just a way of organizing information some way so that you're modeling some conceptual, that you're modeling something, right? So a stack models this, right? That's a stack of books, stack of paper, stack of pancakes, right? So stack is a data structure that provides you with this abstraction, right? The way it works is in a stack, in a programming stack, you have access to the element at the top of the stack, right? So I can grab this book off the top of the stack, right? I can't grab the second book, right? Obviously in real life you can, but in with a programming stack, you're not supposed to be able to grab the second book or the third book or the fourth book, right? What you have to do is you have to take the top element off, and then you can get to the second one, right? Then you take that one off and you can get to the third one, and you take that one off and get to the fourth one. It seems like a simple idea. It turns out to be enormously useful. In particular, whenever you use undo or redo inside of a piece of software, right? For example, in Word or in PowerPoint or something like that, right? When you undo your typing or redo your typing, this is all implemented using a pair of stacks. So classically, stacks only support two operations, right? So it's a very simple data structure. It basically holds a bunch of stuff, and you can only do two things. Right? So I can add something to the top of the stack, right? So in other words, I can put another book on top, right? Oh, that's interesting. How do I do that? Oh, I didn't know you could zoom. Okay, anyway, or you can pop. You can remove the element from the top of the stack, right? So you're not supposed to be able to get to anything in the middle of the stack. Right. So the way this looks is if I start out with an empty stack and I push something onto the top of the stack, so I push the A onto the top of the stack, right? Then you have a stack with one element, and the top element's the A, right? If I push a B, B is now on top, right? If I push a C, C is on top, D is on top, and now the letter E is on top of the stack, right? So I have a stack of 5 elements with the E on top. Pop is just the reverse. So I'm going to take the E off, right? So here, S will be equal to the string E, right? If I pop again, S will now be equal to the string D. If I pop the C, right, that'll be C. If I pop the B, that'll be B. And if I pop the A, that'll be A, and the stack is empty. If you pop an empty stack, you typically get an error, right? You have exceptions thrown. Okay. Now, if I ask you to implement one of these things, right? I think if you've read the notebooks, you saw one way of doing it, right? You saw the correct way of doing it. The wrong way to do it is to use inheritance, right? So a stack looks a lot like a list, right? So when I'm, right? When I'm pushing stuff onto the list, onto the stack, it just looks like I'm adding stuff to the end of the list, right? So empty list, empty list, right? Add an A, add a B, add a C, add a D, add an E, right? To remove stuff, I guess remove from the end of the list, right? So remove the D off the back of the list, right? Remove the C off the back of the list, remove the B off the back of the list, remove the A off the back of the list, right? Lists have methods that will let you add and remove, add to the back of the list and remove from the back of the list, right? So in other words, list does everything that a stack will do, right? So if I want a stack class, why don't I just go ahead and inherit from some sort of list class, right? So I'm going to make a stack of integers by inheriting from inheriting from array list integer, right? And you're going to see that this is like incredibly easy to do, right? So I have this class called bad stack because this is not the way you're supposed to do it. I want to inherit from array list integer, right? So the way you do that is you use the keyword extends in Java, right? So extends means inherits, right? And then you list the class, the one class in Java that you inherit from, right? Now, how do I push a value onto the stack, right? So remember, push adds to the end of the list, right? But that's exactly what the add method does, right? So notice what's in the class. There's nothing in the class, right? There's no fields, right? There's no fields. This thing bad stack, it's already a list, right? So I said bad stack extends array list, which means it is an array list, right? So I can just say add and then add the value, and that will add to the end of this list, right? So I can write this dot add, or you can just write add if you wanted to, and it'll work, right? And that will add to the end of the list, right? Pop is removing from the end of the list. So to pop something or to remove something from the end of the list, you just need to specify the index where you want to remove the element from, right? At the end of the list, the index is always the size -1, right? Again, notice there's no fields, right? But array list has this method called size, and I inherit that in bad stack, so I can just write this dot size, right? That inherits the size method from array list, right? And then I can write this dot remove, which is also inherited from array list, right? To remove that element, right? Remove returns the removed element, so then you can return the removed element back to the caller, right? And that's it, you're done, right? And that is the, that illustrates the potential power of inheritance, right? I just created a brand new class, a brand new data structure, right? In 1, 2, 3, 4, 5, 6 lines of code, right? And I didn't have to do, right? And I probably don't have to test this or this method very, very hard, right? Because I'm going to assume that array list is already implemented correctly, right? And all I'm doing is calling add and remove, right? So this probably works, right? So you've got a fully functioning data structure with very little effort, and you're done. So if you write a main method and test it, it'll actually work, right? Look, you can even print the stack. I never overrode toString, right? Instead, I just use the version of toString that I inherited from array list, and I can get this out, right? So I can print out the stack for free, right? And I can pop elements from the stack as well, right? And you don't have to believe me. You can just copy the code in and stick it into Eclipse and run it, right? So there's push, there's pop, and that's the code that I just showed you there. Ignore this for now, but if you run it, right? In fact, it does print the stack, right? it pushes 0, 1, and 2 onto the stack, and then I can pop 2, 1, and 0 off of the stack, and it all works. Okay. Now, I mean, that's pretty good, right? So you just implemented a stack with very, very little effort, right? And so it seems like a good thing. The problem is, right, because bad stack inherits from array list, you're saying that a stack is an array list, right? And that's not true, right? Remember that the stack is only supposed to be able to push and pop, right? That's the abstraction that stack is supposed to provide. Instead, what we have now is we have a stack that can do anything a list can do, right? Because we said that stack inherits from array list, right? Or in other words, stack is an array list. So now I can grab an element from the middle of the stack if I wanted to. I can change elements in the middle of the stack. I can remove any element from the stack instead of just removing the top element, right? And I can even loop over the elements of the stack if I wanted to. Right? So in other words, you can do all of this, right? Which is back here, right? So I can push 100, 200, and 300 onto the stack, and then I can get the middle element of the stack. Whoops, sorry. Right? I can get the middle element of the stack, which you're not supposed to be able to do. What you're really not supposed to be able to do is you're not supposed to be able to set something in the middle of the stack, but I can do that too, right? So I can set the middle element to -1000, and that works, right? And it works because bad stack is an array list, right? So this is an example of incorrect usage of inheritance, right? It's correct in that it produces the behavior that we wanted. It's incorrect because it produces additional behavior that we didn't want, right? So inheritance should be used only when you really want ISA to exist, right? Stack's not a list, right? Therefore, you're not supposed to use inheritance to implement the stack, right? Now, you shouldn't worry if you do this sort of thing, because here, right? Even experts, so people who have decades of programming experience, will get this wrong, right? So the people who created the Java library, right, provided a class called stack, and it's still in the standard library today, right? Because they stuck it in very early in the life cycle of Java, right? And once you put something into a widely used language, it's very hard to take it out. So if you go and look at the stack implementation inside the standard library, it inherits from a class called vector, and vector is the old array list, right? So the people who designed the Java language made this exact same mistake, right? And they've never been able to fix it, right? Because people went and wrote code using Java util stack, right? And because the people who implemented stack said that it's a vector, people used the class as though it was a vector. And so if the designers of the language try to change the implementation of stack, it'll break a lot of existing code. And that's not a good thing to do. Okay. So once you get it wrong, you're kind of stuck, right? You're kind of stuck with the consequences. So you have to think carefully about when you're going to use inheritance. Okay, so how should you implement stack, right? And so the answer is you should use the stuff you read about last week, right? You should use composition, right? So composition means has a, right? So stack owns a list, right? And if you do that, it's almost as easy as using inheritance, right? So here's better stack. This is a class that uses a composition instead of inheritance, right? Now I'm not inheriting from anything, right? So there's no extends here. Instead, I'm going to use composition to hold a list of integers, right? And I'm not going to let anybody get a reference to this thing, right? As soon as someone gets a reference to this list, then they can use the stack as though it was a list, right? So you have to make sure that you never leak a reference to the internal list, right? So now you have to use composition, right? What does the constructor look like? Well, you just make a new array list, right? What does push look like? Well, remember before I had this dot add value, right? Because before bad stack was a list. Now you just write this dot elems dot add value, right? So now you use your internal list and add a value to that list, right? So there's almost no difference here. Remove is exactly the same, except now you remove it from the internal list, right? And now everything works the way you want it to. So if you go to better stack, right? There's my list. Here's my constructor, right? Here's push, where I add to the end of that list. Here's pop, where I remove from the end of that list. Here's a main method that does everything that a stack should be able to do, right? So I should be able to push and pop. I can print it. Why can I print it? Where is, did I override toString somewhere? Oh, this is not going to work. Okay, so let me quickly show you what happens here. Okay, so I didn't override toString, so when I print it, I'm going to get something funny. Yeah, I get this nonsense, right? So I never overrode toString. So what I end up getting is the version of toString that I inherited from object, right? And objects toString spits out something that looks like this. So that's the name, that's the package of the class, that's the name of the class, that is the value, I think that's returned from hash code, which doesn't mean anything to anybody, right? So you get this, So if you wanted to print out a stack in a nice way, you need to override toString here. I can push onto the stack successfully. I can pop off the stack successfully, right? What I can't do anymore, compared to the bad stack version, if I try to get something from the middle of the stack, that doesn't work anymore, right? You end up with this error here saying get's not defined for stack, right? Similarly, if you try to set, that doesn't work anymore either, right? Because your stack is no longer a list, right? Instead, it has a list, right? So everything that the bad stack let me do, I can no longer do with better stack. And even better is that the error is caught at compile time, right? It's not caught, I don't have to compile and run it to find the error, right? The compiler can catch the fact that the better stack does not have that method or that method. Right, so none of this works, which is great as far as the stack implementation is concerned, right? And so that was that's the quick and dirty, or the very quick introduction to inheritance. Now I can keep going if you want, or I can stop. So just take a quick poll. I guess you can use hands up or something like that. Should I continue or should I end this here? There's only a few of you here actually, so it doesn't matter to me which one, whether you want me to stay or not. Oh, and Victor's already leaving. Okay, so I guess we'll just end it here. Does anybody have any questions about, I guess, assignment 5?
I have a question.
Okay.
So my question is just about the complexity of the shape we need to create in assignment 5.
Yeah.
So how complex does it need to be?
I mean, don't go. Don't make a triangle, for example, right? Or a square or something that's similar to what you already did, right?
So like, is an octagon acceptable?
Well, I mean, no, I mean, it's so that's basically a simple version of a circle, right?
Yeah.
So if you got the circle to work, you can get any any regular polygon to work. Mm-hmm. So I would say no, you should try to do something else, but you don't have to go crazy, right? You should remember that you have all sorts of other commands at your disposal, right? Like you can change the pen size, you can change the pen color, you can teleport the turtle around, and all sorts of other things. So you should do something that's a little more complicated than just a regular polygon. But again, don't go like it. Don't like go out of your way to make something super interesting.
All right, thank you.
Yeah. Anybody else? Okay, I guess there's one other thing I should tell you. There's only 9 of you here though, so maybe I should just put an announcement. And I know at least one of you already knows this. The notebooks, if you are using the notebooks on your own computer, so if you downloaded them, the images are in the wrong place or missing in some of the part 3 notes. So if you're looking at your notes and you're saying, hey, there's no image here, then you're right. It's because they're not in the right place. If you look at the online version of the notes, I think they're all fixed now. It's a little awkward to distribute the corrected notebooks because it involves you having to replace files on your computer. And you may have already edited them. So if you added your own notes, you'll lose those edits when you add them. So for part 3, if you're missing any images, you should look at the online version. And they should be there now. I'm pretty sure they're all fixed now. And if you find some more mistakes, let me know, please, so I can fix them. All right. I guess that's all I have for today. And I will see you for the last meeting next week. Okay.